Good evening, learners. We continue with revising the topic called pressure. Now we are looking at pressure in the liquids. All right, so question number 1, under pressure in liquids, we are asked to name two factors that affect pressure in liquids. Right, by pressure in liquids, we are looking at a situation where you have a container which is filled with a liquid. Let's say it's filled with water. This water has a column height of say height h, and it has a density rho. Remember, density is represented by the symbol rho, but also it is exerted by a force. The molecules in it are being accelerated downwards by a force which is called weight, and such an acceleration is known as gravitational field strength, which is given the symbol G. Okay, so the factors that affect liquid pressure are essentially depth or the height of the liquid column, H, its density, rho, as well as the gravitational field strength of the place, in this case the Earth. So on the Earth, the value of G is taken to be 9.8 newtons per kilogram. Or sometimes this is taken to be 10 newtons per kilogram. Okay, so if they ask you in short, name two factors that affect pressure in liquids, you'd say depth or height of the fluid column, density of the fluid. Remember, fluid can be liquid or gas, and then gravitational field strength. Are any of these two acceptable? All right, so you have 2 marks because they asked for 2 points. All right, number 2, remember we are looking at the pressure in liquids. So number 2, state 2 factors, state 2 facts about pressure in liquids. Okay, facts about pressure in liquids. Pressure in liquids increases with depth. Okay, let's suppose that we have a liquid. We have a liquid like water in a container, and then we mark point A, point B, and point C. Okay, at point A, pressure is less than at B, and point B experiences less pressure, liquid pressure, than point C. This is why if you make a hose, let's say you make a hose at these points, point A, point B, and let water come out. The water will come out through point A at a shorter distance compared to when you let the water come out through hole A, and so on. So hole C will throw water at a much higher pressure. Okay, so this shows that liquid pressure increases with depth. So one of the facts that they are looking for is the fact that pressure increases with depth. With increase in depth, the deeper you go, the higher the liquid pressure. That's what it means. Second point is that pressure increases with increase in density. So liquids that have higher density exert higher pressure. Okay, and let's say you're comparing water and the liquid such as mercury. Mercury has a density of 13,000 kilograms per cubic meter, while water has a density of 1,000 kilograms per cubic meter. So mercury has greater density than water. The higher the density of the liquid, the greater would be the pressure that the liquid exerts at the bottom of its container. The third point is that gravitational field strength would also affect the what? Is going to affect liquid pressure. Let's say you carry out an experiment here on Earth which has a gravitational field strength of 9.8 newtons per kg, and you repeat the same experiment elsewhere where the value of G is very high. Pressure there is going to be higher than it is here on Earth. Okay, very, very important to note. I hope we're together there. Don't hesitate to ask questions if there are any. Number 3, other than the density and depth of a liquid, state any other factor that affects pressure of the fluid. So we have already mentioned here that apart from depth and density, the third one is gravitational field strength, the value of G. The value of G, okay, which on Earth is taken to be 10 newtons per kilogram. This is also a factor that affects liquid pressure. That's why liquid pressure is given by height multiplied by acceleration due to gravity multiplied by density. All right, so these are also essentially the factors that affect. If two of them are kept constant and you change the other, then the pressure will depend on that third factor. All right, if you hold the G and the density and you change the height, it means the pressure will vary, will change according to the change in the height of the liquid. All right, that's very important to note. Unless you have questions, don't hesitate to reach out to us so that we can assist you accordingly. Number 4, a cylindrical container has a base area of area is 150 square meters and is filled with water to a depth of 25 centimeters. Find the pressure due to water on the base. All right, so liquid pressure is expressed as density multiplied by height multiplied by acceleration due to gravity or gravitational field strength. But the density of the water, we need to remember all the time, density of water is simply 1,000. It's 1,000 kgs per cubic meter. This is the density of water, and you should know it off by heart, but in an exam they'll tell you. All right? And the height, we are told the height is 25 centimeters, so we need to change this height to meters. So in order to do that, you simply divide 25 divided by 100, which is equal to 0.25 meters. All right, and gravitational field strength is taken to be 10. G is 10. G is 10 newtons per kilogram. 10 newtons per kilogram. Right, a kilogram. So pressure is going to be, using the factor that pressure is density times height times 10. Sorry, pressure is density times height times gravitational field strength. We shall simply substitute into this equation. Pressure will be 100, will be 1,000, multiplied by 0.25 multiplied by 10, which gives us this. So all you do is just substitute. Notice that we have no business with the area, because in our formula for liquid pressure, there's no area there. In other words, liquid pressure is independent of area. There's no area in the formula. So this one, don't be confused with it. It is not going to be used. All you need is the height, the gravitational field strength, which you must know by heart, but it can also give you in an exam. Unfortunately, this question did not give you that. And also you need to know the density of water, which is 1000 kilograms per cubic meter. Then substitute into the formula, then you find the pressure. Yeah. Number 5, they're saying, explain why a hole in a ship near the bottom is more dangerous than near the surface. Okay, let's suppose we have a ship. Okay, let's have a ship. Let's suppose this is a ship. Okay, a ship which is floating. Remember, suppose this is a ship. So we have a hole here and another hole here. Let's call this hole 1 and hole 2. This one is closer to the bottom, near the bottom. This one is near the surface. So this is the ship's floating on the water. All right, so you remember that the pressure increases with depth. So the hole at the, supposing that water is allowed into the ship, it means that the water, the pressure at the hole 2, the pressure here will be high pressure. Therefore, it will cause the ship to sink. Unlike if the water gets in through hole H1, there the pressure, liquid pressure, is a bit lower. Therefore, chances of sinking the ship will be less as well. All right. So we are saying because pressure increases with depth, the hole at the bottom is going to be more dangerous than the hole at the surface. Why? Because the hole at the bottom will cause high pressure, causing the ship to sink more than it would if the water was acting on the surface. Okay, so we are saying the response that was needed there is, since pressure increases with depth, the hole near the bottom will let in water at a higher pressure than the one near the bottom. That's very, very important to note. Number 6, water dams are built with thicker walls at the bottom than at the top. Explain why. Okay, we just said that liquid pressure increases with depth. The higher the pressure, the higher the depth, the higher will be the pressure. So pressure exerted by water at the bottom is larger at the surface, larger than at the surface as pressure increases with depth. Thicker walls makes the dam able to counter or to withstand the pressure. 2 marks are coming from the fact that pressure is higher at the bottom, and also when the dam is made thicker at the bottom, it will be able to withstand the higher pressure. So pressure exerted by water at the bottom is larger than at the surface as pressure increases with depth. That's why dams are built with thicker walls at the bottom than at the top, because pressure is higher at the bottom of the water than on the surface. All right. Number 7, water tanks in houses are erected as high as possible. Explain. All right. Okay, let's suppose you have a house. Right, this is your house. This is your home, eh? Okay, this is your home. And then you have a water tank. A water tank is usually put at very high place like this. Okay, this is the water tank holding water to be delivered into your house from maybe the source, let's say from water body. Okay, so why is the tank at a higher position like this? Okay, the reason is in order to increase pressure of water coming out of the tap, as pressure in liquids increases with depth. So the idea is just to increase pressure. This depth, you have a tap here, so this height is very, very important. Okay, this height is very important. The bigger the value of this height, the greater would be the pressure. So water will flow into the house through the taps with the high pressure. So it's just to increase pressure. All right. Unless you have questions, number 8, explain why a hole in a ship near the surface is less dangerous than one at the bottom. We have already looked at a question of this nature before. Okay, so there's no need for us to repeat it. Number 9. Question number 9. A drum which is 2 meters high contains water to a depth of 0.5 and oil of density of 0.5 grams per cubic meter extends to the top. Find the pressure exerted at the bottom of the drum. Okay, so here we have 2 liquids which have different densities. Okay, so you have that of water and oil. All you have to do is to find the total pressure. You simply take the density of the water pressure. Remember, liquid pressure is density times height times G. So this is the density of water plus the density of oil. You can call this D. This is D1. This could be D1. This one is D2 for density of oil. So you have D, H, G again. Okay, so notice that the G is the same, is 10 newtons per kg, but then the height will be different. So we are told that the depth of the water is 0.5, which is this one here, and the height of the oil is going to be the difference. You take 2 minus 0.5, should give you this one here. And then you have the density of water, which is 1000, and the density of the oil is 500. Okay, 500 kilograms per cubic meter. Okay, this is obtained by multiplying 0.5 grams per cubic centimeter. Just multiply by 1000, it will give you 500. Then you add the 2 pressures, it should be able to give you that. So please take note that you are able to use the correct formula and substituting correctly to get the answer that is desired. I want to leave you with you pause the video, just go through question number 10 and 11. You can also go as lower down as to question number 12. So I want you to do question number 10, 11, and 12. Just go through and appreciate what is required. I'd like to stop here once again. My name is Mr. Pochilola.